So here's another exoplanet situation. This time it is near the star Kepler-10, and Kepler-10 is a fairly bright star. Okay, this is the exoplanet known as Kepler-10b. So it is the second planet. It is the first planet right next to the Sun, or next to Kepler-10, the star. The orbital period of Kepler-10b is 72,359.64 seconds, or in other words, 20.0999 hours. The orbital radius is 0.01684 astronomical units, and an astronomical unit is the distance from the Earth to our Sun, which is about 150 million kilometers. So we take this number, 0.01684, and multiply it by 150 million, and that gives us the number of kilometers, the orbital radius in kilometers for Kepler-10b. That is 2.526 times 10 to the 6 kilometers, and then add 3 to the exponent to convert that into meters. So 2.526 times 10 to the 9th meters. From our earlier calculations, we found that 4 pi squared over g is 5.9188 times 10 to the 11th. And so now we're going to plug these numbers into Kepler's third law, which has been rearranged to calculate the solar mass. So we have 4 pi squared over g multiplied by r, which is 2.526 times 10 to the 9th cubed, and then we divide that by the square of the period. So let's start by cubing the radius, 2.526 times 10, or in other words, exponent 9, and raise that to the third power using the y to the x key, and we get that answer. Now we're going to divide by the period, and for that we'll use parentheses, 72,359.64, but we square that, close the parentheses, equals, and then we're going to multiply that by g, or rather by 4 pi squared over g, which is 5.9188 exponent 11. And so for the mass of this star, we get 1.82, call it 1.822 times 10 to the 30th kilograms, and that's just a little smaller than the mass of the Sun. Just a little bit smaller than the mass of the Sun. So, and we'll come back and do more calculations about Kepler-10b in just a bit.